Hello everyone. Today we'll discuss the basic function of cells. Let's take a glance at the cell structure. It is the basis of its basic function. Let's see the fluid model of the cells, the chemical composition of the membrane and its structure, chemical lipid and phospholipid cholesterol. It accounts for 20 to 40%, and the protein account for 60 to 80%, and carbohydrate only 5%. And I want to let you know, please keep in your mind the bionics. Whatever you do in your future works, keep biotics in your mind, please. The lipids are amphiphilic. Let's take a glance at the membrane. The membrane consists of lipids and membrane protein. It is a kind of glycoprotein, constructs the carrier channel and etc. The protein can be classified peripheral protein and integral protein. Can be classified receptor protein and recognition protein in the immunocells, and transport protein such as carrier, enzyme protein, and channel proteins. The more important thing is transport across cell membranes. It can be classified to three types: passive transport, active transport, and vesicular transport. For the passive transport, there are simple diffusion, facilitated diffusions. Active transport include primary active transport and secondary active transport. Let's see simple diffusion first. For fat-soluble and smaller molecules, material can diffuse across the cell membrane from high concentration to lower concentration without any help of proteins. The diffusion speed depends on concentration gradient and the permeability of membrane. The transport material by this way include oxygen, carbon dioxide, steroid hormones, and etc. A low osmotic pressure to high low osmotic pressure. For facilitated diffusion, include channel-mediated facilitated diffusion and carrier-mediated facilitated diffusion. Let's see the channel-mediated facilitated diffusion. Ions include sodium and potassium transport through the cell membrane via the channels along electrochemical gradient. Let's see the picture of a channel. When the channel is closed, the ion cannot pass the membrane, and when the channel opened, the ions transport from one side to the other side from the chemical gradient. Characteristics of ion channels include ion selectivity and gating. The ion channel include voltage-gated ion channel, a chemical-gated ion channel, mechanical-gated ion channel, and non-gated channel. Among these, mechanical-gated ion channel most often be overlooked for many years. Please keep in your mind. Let's see the voltage-gated ion channel. It can be depolarization triggers the open of the channel, so the ion can pass through the membrane. The chemical-gated ion channel, for example, the ligand combined with the channel, the chemical triggered the ions passing the channel. Mechanical-gated ion channel is similar. The tension, the stress, shear stress can trigger the opening of the channel so the ions can pass through. So let's summarize. The characteristics of channel-mediated facilitated diffusion include rapid speed and no saturation and no competition inhibition. The gate can have 3 states: activate state, inactive state, and resting state. The resting state of the channel can be triggered by depolarization, so the become activate the opened channel. Before repolarization, should be an inactivated state. It must be repolarization become the resting stage. Let's move to carrier-mediated facilitated diffusion. The substance transported through the cell membrane while the carrier from high to low concentration. The characteristics include specific selection and saturation and competition inhibition. The substance transported by carrier-mediated diffusion include glucose, amino acid, and so on. The type of carrier include uniporter, symporter, and antiporter, called it exchanger. In this picture, there are some symporter and antiporter and symporter. Include simple diffusion, facilitated diffusion, and not consume actual energy for transport, called passive transport. Let's see the active transport, which will consume energy. Molecule or ion are transported through the cell membrane against the electrochemical gradient, which need energy. This is the concept of active transport. The key point compared to passive transport is if it consumes energy. The primary active transport, also called ion pump, need energy directly from ATP for transport. Most classical pump called sodium pump. Sodium from intracellular to extracellular. At the same time, transport potassium from extracellular cellular to intracellular. This is called anti-transport. The sodium pump physiological significance include to maintain the high potassium concentration in the cell and the high sodium concentration extracellular, and to maintain the cell shape, avoid sodium into the cell, and to maintain the concentration gradient between in and extracellular. It is the bioelectricity basis. The sodium pump action can be influenced by the resting potential, and the sodium pump action can pay power to second active transport. Besides the sodium pump, calcium pump and proton pump is also very important. The calcium pump is very important for the function of muscles, and the prototype pump is very important for the intestinal functions. The secondary active transport need energy indirectly from ATP. The transport of 2 or more soluble is coupled. Most often, the sodium moves down its concentration gradient and provide energy for the movement of other soluble against its concentration gradient. We know the gradient for sodium comes from the energy, the consume of ATP energy. So this process is called secondary active transport. It forms energy indirectly from ATP. There also are 2 types, co-transport and counter-transport for secondary transport. For example, the absorption of glucose from intestinal epithelium or renal tubules epithelium by the symporter. This is a very important example for secondary transport. Next type transport, exocytosis and endocytosis. Exocytosis, the particles synthesized by cell are packaged into secretory vesicles in the Golgi complex, and bonded vesicles move to the cell membrane and fuse with the cell membrane. Areas of fusion breaks down. The content of the granules are released. This process needs calcium and both need energy. This is the image of exocytosis. For the endocytosis, it is the reverse of exocytosis. For example, the white blood cell engulf bacteria, also called phagocytosis. And for the white blood cell engulf fluid, pinocytosis. This is an image of endocytosis. It's all simply a reverse direction for the exocytosis. That's all for today's class. Thank you.